We want to look at the Phillips curve and the natural rate of unemployment. For this, let's first look at the connection between the Phillips curve and the natural rate of unemployment. Now, by definition, we know from chapter 7, the natural rate of unemployment is the equilibrium unemployment rate at which the actual price level is equal to the expected price level. I.e., the natural rate of unemployment is the rate of unemployment that makes WS and PS consistent, i.e., WS is equal to PS when P is equal to P. So we have two conditions that lead to U is equal to UN, WS plus PS plus PE is equal to P. Right, so we need WS to be equal to PS plus we need PE to be equal to P, and that leads to U is equal to UN. So there are two conditions that define U is equal to UN. One, the WS is equal to PS, i.e. we have equilibrium, and second, P is equal to PE. Now, in chapter 7 earlier, we found UN from the WSPS model by imposing P is equal to PE in a WS equation and equating the real wage implied by price setting to the real wage chosen in wage setting. So we already found the natural rate of unemployment using the WSPS model where we imposed P is equal to PE and said WS is equal to PS. So UN can also be equivalently derived from the Phillips curve equation given to us as inflation is equal to expected inflation plus M plus Z, where M is your markup from the PS equation, Z is your catch-all variable from the WS equation minus alpha U. So however, now the way we can derive UN from the Phillips curve equation is by setting inflation is equal to expected inflation. Now, why does this work? Okay, because earlier when we found UN, the natural rate of unemployment from the WSPS model, we did that by setting P is equal to PE and WS is equal to PS, right? There are two conditions, P is equal to P and WS is equal to PS. Now we're saying we can equivalently derive the natural rate of unemployment from the Phillips curve equation by setting actual inflation is equal to expected inflation. So why does this alternative way of deriving or finding UN work? Now this works because of two reasons. One, okay, we know, let's go back and recall what actual and expected inflation is. Now, pi t is inflation in year t, which is price level in year t minus price level in year t minus 1 divided by price level in year t minus 1. Now, pi t is inflation expected at time t minus 1 for time t. So this is what inflation you expected at time t minus 1 for time t. So this is price level expected at time t, price level expected at time t minus 1 for time t. So this is the expectation you had that the price level will be at time t while standing at time t minus price level at time t minus 1. Now note, we don't have PET minus 1 here. We just have PT minus 1. Because remember, this inflation expectation is formed at t minus 1 for t. So when you're standing at t minus 1 and forming this expectation for t, you already know what the price level at t minus 1 is because you're standing at t minus 1. So you just have PT minus 1 here. You don't have PT minus 1. Because just remember that this expectation is formed at t minus 1 for time t. So when you're at time t minus 1, forming this expectation, you already know what the price level at time t minus 1 is. So you just have PT minus 1. So this is how we define actual and expected inflation. Now from here we can see that pi t is equal to pi t if and only if PT is equal to PT. Right, so pi t will be equal to pi t if and only if PT is equal to PT. Thus, condition of P is equal to PE is satisfied in the definition of UN when pi is equal to pi, right? We said there are two conditions for UN. The first being that one being that PE has to be equal to P. This condition is satisfied when we set pi t is equal to pi t, because pi t is equal to pi t if and only if PT is equal to PET, right? PT is equal to PET, right? So the first condition in the definition of UN, which was U is equal to UN, is satisfied when the first condition that P is equal to PE is satisfied when we set pi t is equal to pi t. Now the second condition was that we know the two things that we need to D to UN. One is P is equal to P and the other is WS is equal to PS. This is how we derived UN in chapter 7. We imposed P is equal to PE and we said WS is equal to PS. So this P is equal to PE part is satisfied when we said actual inflation is equal to expected inflation. Now what about the WS is equal to PS condition? Now, for this, we need to understand the Phillips curve describes the relationship between inflation and unemployment derived from the equilibrium in the labor market. Right? So the key word here is the Phillips curve describes the relationship between inflation and unemployment, which is derived from equilibrium in the labor market. The key word being derived from equilibrium in the labor market. So in equilibrium in the labor market is where WS is equal to PS in this model. Right? Because remember when we derived the Phillips curve, when we did the mathematical derivation, we did set WS is equal to, we substituted WS into PS, right? So thus WS is equal to PS is always embedded in the Phillips curve by construction, satisfying the WS is equal to PS condition in definition of UN, right? So we know that the way we defined UN is, the way we earlier found UN is that we said P is equal to PE and equated WS is equal to PS, right? There are two conditions, P is equal to PE plus WS is equal to PS. Now, both of these conditions are satisfied when you set pi t is equal to pi et in the definition, in the equation of the Phillips curve, giving you the natural rate of unemployment, right? So the reason we can find the natural rate of unemployment by substituting actual inflation is equal to expected inflation by, the reason why we can find the natural rate of unemployment from the equation of the Phillips curve by setting pi t is equal to pi t is because when you set pi t is equal to pi t, the condition P is equal to P is satisfied, right? We've seen why, right? So setting pi t is equal to pi t means the P is equal to P condition is satisfied because pi t is equal to pi t if and only if Pt is equal to Pt. Second, the Phillips curve is derived from equilibrium in the labor market. So the WS is equal to PS is always embedded in the Phillips curve by construction. So this satisfies the WS is equal to PS part in the definition of the natural rate of unemployment. So that's why when we said pi t is equal to pi t in Phillips curve equation, that gives us UN. Pi t is equal to pi t would ensure Pt is equal to Pt, and the Phillips curve and the Phillips curve, since it's derived from equilibrium in the labor market, where WS is equal to PS. So the WS is equal to PS condition is embedded in the Phillips curve by construction. So when I said pi t is equal to pi t in the Phillips curve equation, so when we said pi is equal to pi e, so then this just becomes 0 is m plus z minus alpha un, and here we could find the natural rate of unemployment. So the key thing to remember from here is that we can find un in two equivalent ways. And remember what un is. It's the equilibrium unemployment rate at which P is equal to PE. It's the rate of unemployment that makes WS and PS consistent when P is equal to PE. So we can find the natural rate of unemployment in two equivalent ways. One, from the way we found in chapter 7, from the WSPS model by imposing P is equal to PE and equating the real wage implied by price setting to the real wage chosen in wage setting. And we can also find UN equivalently from the Phillips curve equation by setting pi t is equal to pi t. So these are two equivalent ways to find the natural rate of unemployment, and we saw why are they equivalent. Because when you set pi t is equal to pi t, you are already satisfying Pt is equal to PET, right? We've already looked at this here. Then similarly, secondly, the WS is equal to PS condition is embedded in the Phillips curve by construction because we've derived it from the labor market equilibrium, WS is PS, right? So we're satisfying this part also where WS is being equated to PS. So a warning over here is, although these both are two equivalent ways to derive UN, but the answer you get from both may not exactly be the same, right? Although there are two equivalent ways to derive the UN, and we looked at why are they equivalent, but the answer you get from both may not exactly be the same as when we derive the Phillips curve equation. Like when we look at the maths behind it, we use some approximations, right? So when we're deriving the Phillips curve equation from the WSPS model mathematically, we're using some approximations. So you will get the exact value of UN from both methods because they are equivalent, but only if, while finding UN from the WSPS model, you use the same approximations you used when deriving the Phillips curve. Because the Phillips curve equation is derived from the WSPS model using some approximations. So you will only get the exact same answer from both when you use the same approximations that you used when use the same approximations when finding UN from WSPS model that you used when deriving the Phillips curve. So these are two equivalent ways, but they may not necessarily give the same answer because the Phillips curve equation is derived using some approximations. So if you're using the same approximations when deriving UN from the WSPS model, in that case, the answer will exactly be the same because these are two equivalent ways.